So are we supposed to go through each question together or discuss them, or what are we supposed to do? I don't remember from our last review.
This is different from our last review because we still had like the homework assignment, but we went through the review. Does that make sense? But
Yeah.
this one, it was just all in the reading.
Yeah.
I'm not sure because I'm like, okay, this is different.
I totally forgot.
You what?
I said I totally forgot to go and look at the review today.
Oh.
Because I was just expecting like, oh, it's just review. There's no prep today. For some
It's
reason.
just in the reading is all it is all the
Yeah,
prep.
it's a bunch of questions, and so you have to do the program and actually run it for a couple of the questions.
Are these the same questions?
No. Like the ones in the review?
Yeah, mine are the same. Because looking at the quiz, I mean, I'm looking at the quiz because it looks like the same question.
Well, I don't think that there's a group quiz for tonight.
No, there is.
Is it really?
Yeah.
Yeah, I'm headed there too. Yeah, we still have our group meeting quiz, but it doesn't look like we have the group collaboration, like to post our video.
Just, but yeah, because I'm in the quiz right now, but.
Okay. I see what it is then. I'll open mine.
But yeah, this one's even different from our last review.
Because it looks like the questions,
Yeah.
at least the first couple are the same. I haven't looked at the rest of them, but.
Wow, there's a bunch of them. I thought
32.
I only had 16 on mine, unless my printer didn't print them all.
It looks like there's 26 on.
Well, I have 32.
I have 32.
Oh yeah, I mean on the reading, like if you go to the stats reading, it said there's only like 26 questions, but yeah, on the quiz there's 32.
All right.
I guess here we go.
Yeah.
So
So,
I
given
want to
the
pass this class.
Yeah.
I have to pass this class.
Me too. I don't want to take it again.
Yeah, no. Okay, well, question number 2 says, given a 90% confidence interval of 45-105 for mean heart rate, which of the following is the best interpretation of this confidence interval?
We are 90% confident that the true mean heart rate is between 45 and 105.
Yep, that's what I was thinking.
Now, if all the questions could be like that, I'd be good. But
Yeah.
I know.
we know they're not.
That would be a nice, refreshing test.
Were you able to get anything back, or did you send an
Oh,
email?
yeah, I did, and I was going to tell you. So it was really simple, actually. So let me get it real quick again.
Because we're probably going to come across it, so.
Yeah, so she said, because I told her, I said we've been struggling with the margin of error on the past couple, and then I gave her a specific question. It was number 16 on quiz number 13. So that she could look at it, and she said to find the margin of error, you find the difference between the upper and lower bounds, and then divide that by 2.
Oh my gosh, really?
Yeah, like super simple. I was waiting for this huge long email of how complex it was.
Okay, so going back to the quiz, so like the question that we just did, between 145 and 105, so you do the difference and divide that by 2, and that's the margin of error?
Yeah, that's what she's saying.
Oh my gosh.
Like, so simple.
Seriously.
Yeah.
Well,
But
at least
I don't know
we use the equation in the video.
Yeah.
And
oh my gosh. That's
but
funny.
still, why could not have been in the reading anywhere?
Yeah, I don't remember reading that.
I don't either, because I'm sure one of us would have caught that and said something.
Yeah. Yep.
That's funny. All right, so researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go, no-go stimulus of males differed from that of females. The researchers randomly selected 20 females and 15 males to participate. The go, no go stimulus required the student to respond to a particular stimulus and not to respond to another stimuli. The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they create QQ plots of both random samples and see that they are, approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? So I think it's yes, the distribution of mean in each sample is normal since the data have been determined normal.
That's what I was thinking.
I would say, and I might be wrong, but I would say no, because if you're comparing the females against the males, there's only 20 females and only 15 males, which isn't a large enough sample size to get a good amount. Does that make sense?
Yeah.
Because if you added the males and females, it'd be 35, which would be a large sample size. But if you're comparing the two, 20 and 15 are not large enough to be considered normal, in my opinion.
Okay.
Okay.
I don't know if that makes sense or if I'm just crazy.
Yeah. Yeah. I
So
guess
let's
the only
try that
reason
one.
why we were thinking yes is because the QQ plot.
Oh,
Yeah, both random samples are approximately normal.
yeah, that would make sense too.
I know.
Let's go with yours since it's a 2-to-1. Let's do yours first because
Okay.
that makes sense.
Okay. Yeah, leave the car on. So these are the ones that I was having trouble with. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? And I tried to find it in our past lessons to like give you the definition of when.
Mm-hmm.
I
Right.
couldn't find it.
So I almost want to say it's the confidence interval for you when O is unknown,
Let me see what I circled on my assignment.
because we don't have our standard deviation. We don't know the standard deviation. Does that make sense?
Mm-hmm.
Yeah.
And
So-
since we just changed everything to not knowing that,
Yeah.
that's one of my biggest things.
Okay, let's try that one because I
Yeah.
had circled confidence interval for the difference of means using independent samples, but
Yeah, that would be my
I think you're
second
right.
guess.
That's my second guess too. Yeah, it would be one of those two, I'm pretty sure.
Yeah.
all right.
My husband had to run back to the church because we had taken some of our bowls, and I come home like, one's missing. So so those big, huge metal bowls that a lot of church houses have, well, my big bowl is obviously tiny compared to that, but it got stuck with those bowls.
No.
Okay, question 5. A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. 95% of the confidence interval for the mean savings account balance of bank customers is found to be 3,402.08 and 41.42.75. Wow, I cannot talk tonight. Which of the following would produce a confidence interval with a smaller margin of error that is 95 confidence interval? Wasn't it the 90%? I don't know. Okay, I gotta read these again.
In my homework, I said obtain the balances of 90 bank customers rather than 30. But I could be wrong.
That's
what I'm thinking.
I'm trying to remember because I'm trying to remember when you change what makes it smaller or larger. But I think the larger bank customers would.
Because you have a larger sample, so
Yeah.
Yeah.
larger the sample, the closer to 0 or something like that it becomes, right?
Yeah.
If I remember right.
Closer to the mean.
Okay. So the next one says a factory makes propeller drive shafts for ships, a quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts. Input your answers for the margin of error, lower bound, and upper bound. So determine the margin of error.
So
This one is the 1.96
Yeah, this
times.
one have to be that one.
So is this one the 1.96 times, is it times 2 divided by the square root of 1,000, or is it the other way around?
well, I think it's, oh yeah. Well,
What's the equation? What's the actual equation?
That's what I'm trying to remember. I grabbed
for
the
the
wrong
margin
tablet.
of error, it is m equals the z, which is the 1.96, and then you times that by the standard deviation divided by the square root of n.
So that would be 4 then, right? 4, because she randomly selects 4 drive shafts made at the factory.
But does,
So this has got to be the other one, right? Isn't there another one where we like use those two numbers that were given, the 1,000 millimeters and the 2 millimeters? Because we have the standard deviation is 2 millimeters and the sample mean of 1,000 millimeters.
So we wouldn't use
I
that
think
because the n would be 4 in this, wouldn't it?
Right, you're right.
yeah. So I'm getting 1.96.
Which that makes sense. That's what I have too, because we just canceled out 2 and square root of 4 by 2 over 2.
Yeah.
Is that what you have too?
Yep.
Seems kind of silly, but that's it.
So then the lower bound.
So in the homework,
We lost her.
Did we?
Yeah.
No. Is
I feel
there?
like we
Go
I feel
ahead.
like we should be pulling up something in the program.
I know, that's what I was asking. Is there another way to find the upper and lower besides the program? And if there, because how do we find that?
That's what I was just wondering.
so apparently my car's Wi-Fi is not any better than my house's Wi-Fi. Because I just was like, blah, 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 blah. Are you there?
No, we're not. We're like, we lost her.
Yeah.
Yeah.
You said, so in my homework.
Yeah.
And that's all we heard.
They have the A, B, C, D. And I have the 998.040 for the lower bound and 1001.960 for the upper bound.
So how did you get those?
Yeah.
Because they were multiple choice in the homework.
They were?
Yeah. And then you go 1000 minus 1.96, which is the margin of error at the 95% confidence interval, I think.
Oh, yeah, that makes sense.
That does
Yep.
make sense.
Because I'm thinking there's like this complicated equation to do it, but it's really just that upper and lower,
Yeah.
just adding and subtracting. Okay.
So 998.04 for the lower. Is that what you said?
998.040. And then the upper, I have 1001.960.
Okay.
Okay.
And then to do the next one, to assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of 9 times, and the mean of the weights is computed. Suppose the scale readings are normally distributed with unknown mean and standard deviation of 0.01 grams. How large should N be so that a 95% confidence interval for you has a margin of error of plus or minus 0.0001? And then I guess we could calculate 1.96.
I feel like there's an equation for this one. Is there?
Well,
I remember one.
in the reading, it had multiple choice, and so I kind of think I know what it is, but I'm going to see if it goes in the equation too. And so
I remember doing something like this. There is an equation.
Yeah, that's what I was thinking too. Did we learn that back in Unit 1?
I think so. Are we going through all the units at every exam?
It just should be just the Unit 2 ones.
yeah, I thought it was just what we've been working on.
But if you go through the instructions, it says also review exam 1.
Oh, does it really?
Yeah.
Oh,
Oh, that's, yeah, you should go over review.
So that's going to make this even more fun.
well, because they had multiple choice, I used the 12,988 in my figure and got the 0.0001 as the answer.
Okay.
Okay.
So I think it's 12,988.
Okay. That makes, I mean, I have the review open too, so I can see that. I did go through them and kind of tried to go through them, you know, as I was trying to do 10 million things today. So I had to make 2 pounds of brownies and
That sounds delicious.
and we used, and I still have 1.5 pounds of brownies. So
I was gonna say if I had to make 2 pounds of brownies, I'd end up with like 1/2 pound left.
no, I still have 1.5 pounds because I had other people bring brownies too, but you never can be too sure with brownies.
Yeah.
So, okay. So are we good with that one for number 9?
I hope so. I hope I'm not telling you guys all the wrong problems.
Well, we got 3 or 6, I guess.
Yeah.
And I'll have to go back and find that equation. And if you guys find it too, that would be helpful.
Yeah. And we lost Lorinda again.
Okay.
Okay, this one, when she comes back, we can discuss it. But I think this one's the hypothesis.
I didn't keep talking to myself as long as I did last time.
I just look up and I'm like, Lorinda left the group. Like, oh, I'll just wait a minute. So this one, I think it's the hypothesis is the less than 1250. That one?
Yep. Yeah.
Because it tells us that they think it's smaller than 1200,
Yeah.
1250.
So on mine, it's the bottom one.
That's what it is on mine too.
Okay.
So an 11 says, in a statistical test of hypothesis, we say we reject the null hypothesis with the level of significance alpha if
It's lower, less than, right?
the p-value is less than.
I think I'm finally starting to remember how that works.
Yeah, the more we do it, the more you remember.
Yeah. Okay. A group of statistic students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect the GPAs from an anonymous random sample size of 15 from each of the 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use the ANOVA hypothesis to hypothesis test to answer their question? So the ANOVA wasn't bell-shaped, was it?
No, it was right skewed.
So it's going to be no.
Yeah. I put no, they don't know the true standard deviations of each sample.
Yeah.
Yeah, that's what I was just thinking. Because I'm like, it's not bell-shaped for ANOVA, so I know it's not going to be yes. Okay. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample size is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has
I don't remember those 2.
and that was Unit 1, wasn't it? Those ones?
So type
Yeah.
1 is rejecting a true no hypothesis.
Okay.
And where's my type 2 note? And type 2 is failing to reject a null hypothesis, I think.
That sounds right.
So then would it be a committed
Or,
type 1?
or agreeing with an incorrect one. I think that's what type 2 is.
Yeah. I almost want to say it's incorrectly used a 0.05 significant test when she should have computed the p-value. Does that make sense?
I think it, I don't know. I think it's the type 1 and type 2 errors.
It could be.
And
Yeah,
so,
I'm trying to figure out which one's which.
I know, that's what I'm. Are we really not given if we know if we've done these right or wrong on the quiz? Or not the quiz, the reading?
Mm-mm.
You know how on our homework assignments we can check?
Yeah, there's nothing here.
so I think it's a type 2 error because she rejects the null hypothesis.
Okay.
So she agreed with something that was wrong, right?
I just did a recap, like on the reading. You can hit the summaries.
Yeah.
So it talks about a type 1 error is committed when we reject the null hypothesis that is in reality true. We talked about that. A type 2 error is committed when we fail to reject a null hypothesis that is in reality not true. The value of A is the probability of committing a type 1 error. So I almost want to say we're talking about a type 1
Yeah,
or type
that
2.
makes sense. Or type 2?
Yeah, because a type 2 error is committed when we fail to reject the null hypothesis that is in reality not true. The value of A is the probability of committing a type 1 error.
Yeah, so a type 1 error is rejecting a true hypothesis, but she rejected the null hypothesis, which most likely is true because hers is different in two different samples.
Yeah.
I would say
Right.
2.
So are we going with the type 2 error?
I
Yeah.
hope so. I
I
hope I'm.
think it is.
I guess we'll see how we do when we're all done. On the plus side, we only have to go back and do the ones that we missed.
Yeah.
Because we know which ones we get right.
Yeah.
So let's see. If the level of significance A is very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? And I put, by reducing the probability of committing a type 1 error, we increase the probability of committing a type 2.
That's what I was just looking at and
Yeah.
thinking.
That's what I was
That
thinking.
Since we all think the same, we'll go with that.
Then the next is the nicotine content in cigarettes of a certain brand is normally distributed with a mean in milligrams U and a standard known deviation of 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand give a sample mean of X equals 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis.
Is there a number that we would say that it's close enough that you wouldn't consider it, or is it anything? 5.
So their standard deviation was 0.17, and the hypothesis is testing it at the 0.05 level of significance. So I think it's fail.
I was saying fail to reject.
Yeah. Yep.
Okay.
She has a sippy in the diaper bag.
Okay, so 16 says you would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? So would you say a paired?
That's what I was just thinking. Because we're talking about male students and female students.
Yeah.
I thought it was independent because
It's grouping them together. No.
like knowing what the male students is doesn't have anything to do with the female student. Let me look at my notes.
That makes sense, though.
Yeah, that does make sense.
Because we're asking for each group, not what it is together. So it's not a differences. So it wouldn't be our paired.
Because the paired is they ran the mile at this many minutes, and then the next day they ran the mile at this many
Right.
minutes.
Yeah, that makes sense. Yeah,
Yep.
I would go with independent too then.
Hey, we're halfway done.
Woo!
Since there's 32 problems, and we just did number 16.
Okay, so this is where I got that from. In contrast to dependent samples, two samples are independent if knowing which subjects are in group 1 tells you nothing.
We lost her.
It like builds a suspense though. It's making this great.
I
Like,
know.
oh, what was she gonna say? Just kidding.
What was she saying? Come on.
Here I am. Did you
Okay.
hear all that?
We were just saying you just keep building up the suspense.
Yeah.
I can't win. Did you guys hear my explanation that I
Not
gave?
all of it.
Not all of it. You started into it.
Oh. Anyway, it sums up the. I think it's the independent.
Yeah.
All right, 17. An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are not, or when they are next to each other in sibling order. Should she use a hypothesis test on an independent or dependent sampling? I think it's dependent.
Mm-hmm.
I think so too.
But then the sister's academic achievement depends to some degree on her brother's. I don't think that's right.
So
I don't think so.
Like the brother, so as to compare his academic achievement to his sister, you must include.
Yeah.
Yeah.
Yeah, that makes sense.
Now this is when we have to get into
Dissolved organic carbon.
But now we get to use the program, and it usually gives us most of our answers.
Yeah.
yes. This part of it was a lot easier because you didn't have to use your brain as much.
Well,
Sorry. All right.
Hey, I'm okay with that.
Yeah.
Except for the first question is one of those. Which one do you use?
Oh.
From the beginning, I'm like, I don't know.
Boy, it's taking its sweet time loading that program tonight. At least for me, it was.
Mine came up pretty fast.
Mine finally loaded. Okay. So this one, we just do what we've been doing, like the descriptives, explore, right?
Yeah, well, I did analyze, and then I did compare means of a one sample t-test.
Oh, yep.
Yeah.
With the test value of 1.96, right? No, because that's already done. It's already done for us. In the options, test value 0.
Yeah. So would this, let's see, because we know the standard deviation then, right?
Yeah.
So the confidence interval for you when O is known?
I was thinking that. I'm trying to see the other. Yeah, I would say that.
Did we lose Lorinda again?
No, I'm here.
Oh, okay.
I'm just reading it again.
It's okay. I'm trying to go through.
Okay, we'll go do
Good.
the confidence when the standard deviation is known.
Because we
Yeah.
know it after running that.
Yeah.
Which of the
So-
following is the 95% confidence interval for this analysis? Input your answers for the margin of error, lower bound, and upper bound.
So 15.21737 minus. So for the margin of error, I got 2.0245.
Oh, there it is. My card's really dark. I lost my calculator. I got 5.98.
I'm working on it right now.
What'd you get, Justin?
I got 2.025.
How did you calculate it?
Because I used the one equation she gave me where you find the difference between the upper and the lower, and then divide that by 2. Which way did you do it?
I did MER equals the z or t-score times by the standard deviation over the square root of the number.
Okay.
I did that too. I got 1.896.
Oh boy. So,
Since we all have three different numbers. So I did 1.96 times the 4.325772 divided by the square root of 20.
okay.
Right?
Yeah, that's 1.90 or 1.9 because you round it up, don't you? 1.895 or 896.
896.
Because
Okay.
how do we determine when to do each equation? Because I remember when last, I don't, because is this the one that we were, the
So
equation?
this one,
No, because this one we
don't
have the
differences.
information. Yeah.
Oh, the other ones we did not?
Right.
We-
The other ones we had more than one category that we were working with. Does that make sense?
Oh, okay.
Like we had to go in and then we had to analyze or transform them.
Okay, that makes sense.
Am I thinking right?
Yeah.
So
Okay.
what did you get for that then?
1.896. Because we rounded up to the third.
Okay.
And then luckily, those upper and lowers are already there.
So do you have the lower bound? That just seems high to me. 11.168.
Yeah.
That just seems really high, but I guess it is. So then I guess if I look at the numbers.
All right. Well, now we got to figure out Hummers.
It's my turn to get kicked out.
I saw that. I'm like, wow.
Oh, my turn will probably be next week because I won't be
Yeah.
on my internet. Thursday when we meet, I get to do it in the airport. So
Oh,
Oh,
nice.
because we'll be flying back. We fly in on Monday, so I don't think I want to try to meet on Monday.
Yeah. So for some reason, my SPSS software is frozen in the middle of my screen.
Nice.
Ugh. There we go. Nope. Goodness.
So this one we're gonna want to transform it, right?
Yeah.
Mhm.
Are we transforming the year or what are we transforming?
The prices.
How do you know what to transform?
Because it asks.
Oh, does it say it there?
Yeah. So on
Uh-huh.
the
Yep.
following is the 90 for the listing prices.
So transform, automatic recode.
Did you guys do 22 already? No, you didn't, right?
Well, we're on 22 right now.
Okay.
If I would have just finished reading that part, I would have saw that it told me to do that. So that's, are you sure we do the price on that? It does though. Because I end up with like 49, 22, 42 when I did the price code. That form.
Because is this the paired one? Is that how we analyze it?
Mm-hmm.
Right?
So it's not.
What's that, buddy? Oh, cool.
Yeah.
So any clue on how to get the software to shut down? Because like in Windows, you can do Control Alt Delete.
Can you do, are you on a Mac
Yeah.
and it won't let you quit it?
Mm-hmm.
There's a command Q, which is quit, force quit, I think, right?
I think so. I know how to force something to quit on a phone.
Yeah.
So we want to recode. I'm looking at this again. Is this city
We want to recode the city.
to group 1 and group 2, not
Yeah.
the price.
I'm not sure.
So it's the city because we want to know if there's a difference in mean listing prices between Hummers for sale in Los Angeles, group 1, and Hummers for sale in New York, group 2. So we want to change Los Angeles and New York into 2 groups.
Okay.
So does that make sense? That's why we would do the city
Yeah.
instead of the price. Because if I do the price, I have numbers clear up to 90 something.
Okay.
Sorry, I'm still dealing with my stupid
And you
program
do,
that doesn't.
it's so, and then you do the paired samples and you compare the city and the price.
Yes.
So I think I'm gonna have to turn my computer off and start it again.
Okay.
Okay.
So I'll send you another invite because I think it'll, whatever, it'll shut that one off.
Or we can try to get you back into where we're at.
Yes.
I bet if you clicked on that link, you could get back into it. Or is it because you're the one that did it, you might not?
Yeah. Let me see if I can make you guys presenters. I'm not going to be able to because I can't even get this. I have a big SPSS box in the middle of my screen and I can't click on anything else.
Okay.
So I'll be right back.
Okay.
Okay. I guess we'll find out.
Yeah. So after you, so you did the paired samples test, right?
That's what I'm well, so
Or-
that's not a familiar screen to me when I do the paired sample test. I want to say we do the independent samples t-test.
Okay.
I could be wrong.
I'm not sure. I gotta study that better. I'm not sure which one to use still.
I know, I usually have to go back through the reading and figure
Yeah.
it out.
I think you're probably right with the independent. Because I guess if we go by the definition, does the sale in Los Angeles depend on the sale in New York?
Yeah.
So I would say no.
Gotta put it in right.
Because did you put the...
So your price variable. Okay, I just got the text from her, but I can't sign in through text.
I can send email it to you. Maybe. Did you get an email for it?
No, I just got the text.
Okay, let me send it to you real quick.
And now I just got the email.
Oh, there it is. Yeah.
So I guess we'll close out of this one here in a minute.
Okay, yeah, I'll see you over there.
Okay.